All right, welcome back to topic 1.8, example 2. Find the limit as x approaches 0 of the sine of 4x over x. So here, if you notice, we're getting pretty close to where we want to be, which is the limit as x approaches 0 of the sine of x over x. So we want to make sure that our function is similar to that one, right? Like sine of x over x. So let's do a couple of algebraic tricks that we usually do, which is algebraic tricks. It's usually multiplying by 1 or adding 0. So in this case, we're going to be multiplying by 1. So this is equal to the limit as x approaches 0 of 4 times the sine of 4x over 4 times x. And if you notice right there, this is why I'm multiplying by 1. There's a 4 right there and a 4 right there. So right here, if you notice, now that I have that means that I can apply one of the properties that I'm familiar with, which is a constant multiple property, which means I can pull that 4 in front of the limit. So this would be equal to 4 times the limit as x approaches 0 of the sine of 4x over 4x. And now, since both of these are the same, now I can say that's equal to 1. So this is going to be 4 times 1, right? The constant that was in front. So therefore, my limit is just positive 4. All right, now let's look at example 3. So on example 3, there's 2 different ways. I'm going to show you one of them. So here we have the limit as x approaches 0 of 1 minus cosine squared of x over x. Now, again, let's see what happens. If I do try to apply direct substitution, I'm going to get 1 minus 1 on top, which is 0 divided by 0. So that's not going to work out for us. So now if you notice, this may not look like it, but this is actually a difference of 2 squares. So we can take advantage of that. So here I'm going to apply the limits as x approaches 0 of 1 minus cosine squared of x. So I'm going to say the limits as x approaches 0 of 1 minus cosine squared of x over x equals, right? So difference of 2 squares, the limit as x approaches 0 of 1 minus cosine of x times 1 plus cosine of x, and then everything divided by x itself. All right, so that was the trick right here. In this case, we can factor it, right? It may not look like a difference of squares, but it is a difference of squares. So now that we do that, we can again apply the property. If you notice, one of these, right, one of these is already one of the limits that we pretty much are taking for granted right now, right, that we should be able to use. So this is going to be equal to the limit as x approaches 0 of 1 minus cosine of x over x times the limit as x approaches 0 of 1 plus cosine of x. And again, if you do direct substitution, we know that the first one is for sure going to be equal to 0, right? It was one of the given theorems. That was the second one. And then times the limits as x approaches 0, cosine of 0 is positive 1, so that's going to be times 2. So that's equal to 0.